This is the 2024 Higher Level Applied Maths Leaving Cert paper, question 8. The company director wishes to design a business plan to promote her brand over 4 years. Each year she chooses from a number of different promotion strategies. She estimates the profit, positive value or loss negative value of each strategy in thousands of euros. She draws the network below to help design the most profitable plan, where the edges represent the different strategies and the nodes represent the possible states associated with the plan at a given point in time. X and Y represent the start point and the end point of the plan, respectively. Use Bellman's principle of optimality to calculate business plan that maximizes profit. Relevant supporting work must be shown. I put the table in here on the right, table of values, and I've started a table down here where I've included the stage, the state, action, and value. So I have 4 stages, and in each stage then we have the states, G, H, and I in the first one, D, E, F in the second one, and so on. The actions then are basically the arcs, so G to Y, H to Y, I to Y, and so on. And I'm going to put in the values here on the right hand side. So let's start. The first action here is G, Y. And if we look at G to Y here, it has a value of 6. I'm going to put in 6 here to start with. The second one is H to Y, and if we look up here it has a value of 5, and the third one, I to Y, has a value of 7. So we're going to star each of these and move on to the second stage. So if we look at the second stage here, we have D, E, and F. So on the graph here we're looking at D, D, E, and F. So D goes from D to G, D to H, and D to I. E goes from E to G, E to H, and E to I, and F does the same. So we're going to look at all these values. First one is D to G. So we look at our table here. D to G has a value of -5. So let's put that one in. So D to G has a value of -5, but we've got to look at this G here, come up to G here, and look at its value here of 6. So we've got to add 6. That gives it a total value, or a net value if you like, of +1. Let's look at D to H. So D to H has a value of -3. So we're going from D to H here, so it has a value of -3. So if we put in -3 here, we're going to H. So if we look at H here, it had a value of 5, so we've got to add 5. That gives us a net value of +2. Same with DI. Let's have a look at DI. So DI up here has a value of +3. So we're going to put in +3 here. And then it goes to I, so come up here to I, across here to this value here, which is 7. So +7, that gives us a net value here of 10. So from the state D in stage 2, the maximum value, remember we're trying to maximize profit here, so we're trying to maximize each of these values. I'm going to star the largest one of these 3, which is 10. So this is what we've got to do the whole way down along. Let's look at the next one then. We have E to G. So if we look at E to G, it has a value of -2. So we're going to put in -2 here, and then if we come back up along here, we've got G here, G 6, so we're going to add 6. That gives a net value of 4. E to H. E to H has a value of 5, so we put 5 in here, and we're going to add 5. That gives us a value of 10. If we look at E to I has a value of 6. So we're going to put 6 in here, and then it goes to I, so we're going to add 7, which gives us a net value of 13. So I'm going to start 13, that's the largest of these 3 here. Okay, next one then, we have F to G. Well, F to G has a value of 4, so we're going to put 4 in here. We're going to add to G is 6. So we're going to add 6, that gives us a value of 10. We've got F to H as a value of 3, we're going to add 5, that gives us 8. F to I has a value of 2, we're going to add 7, which is a value of 9. So I'm just going to do these a little bit quicker now. So the largest one here is 10, so we start at the 10. When we come down along here, we've got A to D, which has a value on the arc of 5. When we go back up to D, we can see that, so we're starting here at D, so if we come up to D here, the largest one here is 10. So we're going to add 10, which gives it a net value of 15. A to E has a value of -2 on the arc, and if we come up to E here, we can see that its largest value is 13, so we're going to add 13. So that gives us a net value of 11. A to F had a value of -5, and F, we can see here, had a largest value of 10 in the previous stage, so we've got to add 10, which gives a net value of 5. Highest value is 15, so we're going to start at 15. So let's continue on then. We have B to D, which is 7, and D is 10, so that's 17. B to E has a value of -3. We're going to add 13, which gives a net value of 10. And then we have B to F, which has a value of 4. We're going to add 10, gives a net value of 14. Highest one there is 17, so we start at 17. Okay, let's move on to the next one. So C to D has a value of 5. We're going to add 10, which gives us 15. C to E has a value of -4. We're going to add 13, which gives a value of 9. And then C to F has a value of -1. We're going to add 10, which gives us a value of 9 as well. So we're going to star 15. And then finally we're on stage 4, so let's just put in all those values. Let's see, we have X to A, which has a value of -11. We've got to add the A, which you can see up here has a value of 15, the maximum value of 15. So we've got to add 15 here. So that gives a final value of 4. We've got -13, and for B the maximum value is 17, so we're going to put in 17 here, which gives us a maximum value of 4 as well, a net value of 4 I should say. And X to C was -9, we're going to add 15, you can see 15 was the maximum value back here, so that will give us a net value of 6. So that is what we're going to star here, and this is actually one of our answers. So we have to use Bellman's principle of optimality to calculate the business plan that maximizes the profit. Relevant supporting work must be shown. So the maximum profit then, so the maximum profit is, remember these are in thousands, so it's going to be 6,000 euros. So the maximum profit is 6,000 euros. What we've got to do next is just follow these starred values back. So the path, the optimal path, is X to C, because this one gives us our maximum profit. And then if we go up to C, we can see that we need to go to D, so it's X, C, D. Then if we go up to D, up here we can see that we had a maximum value of 10, and that went to I, so it's DI. And then if we go to I up here, we can see that we went to Y finally. That's the sync node. So that's our optimal path, and that's our maximum profit. So that's it for part A1. Let's have a look at part 2. What have we got to do? We've got to state one difference between Bellman's principle of optimality and Disker's algorithm. So I'm just going to state one here. I'm going to say that Disker's algorithm is a greedy algorithm. Bellman's is not. We could also say here that Disker's algorithm can't have negative values, but Bellman's principle of optimality can have negative values. But we were only required to state one, so that's it for part 2. Okay, so in part B we have the algebraic formula below is written in terms of force, mass, displacement and angular velocity omega. So square root of 4fs over m omega squared. Use dimensional analysis to show that this formula has the same units as the units for displacement. So if we start with what we're given, we've got 4fs over m omega squared. So let's stick in the units then. We've got square root of 4 we can ignore because it's a constant. Let's see, force is kilograms meters per second squared, and then we have displacement here which is meters as well. On the bottom we've got mass which is kilograms, and then we have omega squared. So if you think about omega, omega is the angular velocity. So if we have, let's say, a circle here and this is the radius, let's say in meters, the angle here, let's say this is r as well, this will give you 1 radian if the distance from here to here is the same as the radius length. So in other words, the angle is given by the arc length over the radius length. So that's really just going to be, if we're talking about meters for example, it would be meters over meters, which is just 1. Really we're just looking at radians having no units. So it's radians per second, which is, if you like, no units over seconds. So really what we're looking at here is kilograms over seconds, and then because it's omega squared we've got to square it. Okay, so this is what we're left with. Let's just mess around with this and see where we end up. We have the square root of, let's write down the top, so the top is going to be kilograms meters squared over seconds squared. We got to multiply that by fraction on the bottom, which is seconds squared divided by kilograms. So if we do all of that, we'll find that the kilogram will cancel, seconds squareds will cancel. So what we're left with is just the square root of m squared, which is m. This is meters and this is the same unit as displacement. That's it. That's it for this question. So that was not too bad a question I think overall compared to the others.